While we're setting up new objectives to secure global net zero emissions, electrical energy demand is rising fast. Peaks in supply and demand are getting more complicated to manage. Acceleration of the phase-out of fossil fuels, the switch to electrical vehicles and roof-mounted solar panels comes at a price. The electrical supply must increase accordingly. But the pace of change is too fast. Our old infrastructure is struggling to stay reliable and be transitioned to green at the same time. Power outages will become reality if we don't act now, triggering major economic damage and put lives at risk. So how can we tackle this issue? The traditional solution would be to build more power plants and substations and to install more cables. However, expansion capacities are limited because we need time and space we no longer have. Another vision to accelerate the energy transition without changing the existing electrical infrastructure uses what we know as microgrids. Decentralized groups of electrical sources and loads that can either complement the main grid supply or disconnect and function autonomously depending on the weather or energy costs. In common alternating current microgrids, a central brain, known as a microgrid controller, uses multiple sensors to take such decisions by communicating in real time. Then there is our own vision. In our current OS microgrid, thanks to embedded microbrains, it's the equipment itself that takes action depending on the actual power available in the DC microgrid, as reflected by the voltage level. No need for an additional system control layer. The conversion between AC and DC is easily performed by a bidirectional active front end at the microgrid door. For example, during a sunny but cold winter's day with active solar panels and full batteries, the HVAC will know it's the perfect time to make the meeting room warmer, and the electric car will recognize a good opportunity to recharge. If the microgrid is producing more than needed, the extra power will be pushed onto the main grid. On the contrary, when it's getting cloudy and the batteries are almost empty, the AFE will draw the power it needs from the main grid. However, if this main grid is down, we'll have to eventually switch the equipment to emergency mode and use the minimum required energy for the essential building activities. The current OS protocol defines DC microgrids with a native automatic response to power availability that makes microgrids fast. Current OS microgrids can be installed quickly by electricians and integrators and do not require a microgrid management system. Simple. Extensions are simple to implement. Just add on new equipment. Direct current electrical distribution is also logical when linking DC sources and loads, like PV, batteries, EV, lighting, and IT devices. Safe. This DC system does not require central real-time control systems with a controller and sensors. Therefore, it is naturally fully resilient to communication losses and cybersecurity issues. The current OS Foundation ensures availability of this open protocol to any manufacturer that would like to make its products smart and ready for microgrids. This protocol is the proper basis for a global rollout of decentralized DC grids and will play a major role in the energy transition. Find out more about our current OS on our website and prepare your assets for the future.